Hello everyone. In this video I'm going to discuss about the master theorem, that is one of the method to solve a recurrence relation. So it is a method that is used to solve recurrence relation. Master theorem cannot support all forms of recurrences. Master theorem is not capable of solving all type of recurrence relations. There is something that has to be fulfilled for a recurrence relation to be solved by master theorem. So they can solve some specific one. They are as it says that there has to be some conditions for the equation has to be solved by master theorem. That is, if we are having Tn which is equals to Atn by b plus Fn. Fn is equals to nothing but order of nk log Pn. So Tn is equals to Atn by b plus nk log Pn. So this is the statement that a recurrence relation is always in the form of, that we have studied in the substitution method also. So there is a condition to be solved in master theorem, that A has to be greater than equal to 1. A should be greater than equal to 1. A can be 1 and also greater than 1, but not less than 1. And B has to be greater than 1 for sure. It cannot be 1, it has to be greater than 1. Now we are be given some basic questions, and we have to analyze our question, that whether it is in a pattern of master theorem or not. And secondly, there is a pattern, that how should we solve it. There are some steps involved in it, that we are having these conditions has to be satisfied. These are the conditions that has to be satisfied. Now there are some conditions that more need to be solved. Now how we solve it is the thing. So these are some of the set of conditions that has to be fulfilled. That firstly we have to find b raised to the power k, that is k is the part of a function and b is the value that has to be greater than 1. And if there are three conditions, we have to check for all the three and accordingly react to the condition and provide the time complexity. So the first is, the if a is greater than b raised to the power k, that function, the Tn will become order of n log base b a. We'll put the value of a, what is the value of a, what is the value of b, we'll put the value of a and b respectively. So if a is greater than bk, we'll write Tn theta n log base ba. The second condition says that if a is equal to bk, we are having three conditions: a is greater than bk, a is equal to bk, and a is less than bk. So the first condition is fulfilled. The second condition will move to the second condition. It says that a is equals to bk. So there are three conditions that we have to check for, that if a is equals to bk, then p is less than -1, p has to be equal to -1, p has to be greater than -1. So we have to check for the three conditions. If we have find it that a is equal to bk, then we have to check for three more conditions, that is p less than -1, p is equals to -1, or p greater than -1. So if p is less than -1, the function or the time complexity will be n log base ba, the same as that of the first one. The second is, if p is -1, if the value of p is -1, which is p is a part of a function, so our time complexity becomes n log base ba dot matlab multiply log square n, right? The third condition is if p is greater than -1, so our time complexity becomes n log ba base ba dot log in the power p plus 1 and with the function of n, right? So this is the three parameters and we have to check it. The third condition is that if a is smaller than b raised to the power k, so the two parts we have to check for again. We have to first check that if our condition satisfies that a is less than bk, we have to check more two conditions, that p has to be less than 0 and p has to be greater than or equal to 0. It can be 0 or has to be greater than 0. So if our p is less than 0, the function will become theta of n raised to the power k, right? And the second is that if p is greater than or equal to 0, our function becomes order of time complexity of n bar k log pn. And it is to be noted that the value of this is the formula. We are having the values of k and p, so we have to write those values. I'm going to tell you one question that how we solve a problem, a recurrence relation problem using master theorem. So here we are given with one question, that is Tn is equals to n, the function will be n when n is less than equal to 2 and 2t n by 2 plus an square, and this function will be when we are having n is greater than 2. So as we are required to see that are they fulfilling the conditions to be solved in a master theorem. So we can see we are having 2t n by 2 plus an square. So I can see here it is tn. So here are at n by b, at n by b plus fn is the generalized form that our function has to be in master, can be solved in master theorem, can be solved by master theorem. So we can relate that our a is equals to 2, a is greater than equal to 1 and b has to be greater than 1 and here b is 2, so b is greater than 1. So these two conditions are satisfied. Now we have to find the time complexity of it. So firstly we'll write down the values that we are given with. So we are given with a is equals to 7, sorry it's 7, so 7 is greater than equal to 1, 7 is greater than 1. So we are given with a is equals to 7, b is equals to 2 and function that is an square. An square is the function, it has to be in the form of nk log pn. So it is in the function has to be in this format, but it is in an square. So n power k log pn is equals to n square log 0n, because here we are having an square, right? So n square means we are having the value of n value only, we are having the value of k only, not of p, right? So we will be having nk log 0n is equals to n square log 0n. Here bk, k is equals to 2 as n square is there, so n power k, so k is, we are given with k, so k is 2. We have to find bk for performing the rest 3 solving the rest 3 conditions and to get the time complexity of the formula of the question. So bk is equals to, b is 2 and k is 2, so 2 raised to the power 2 is 4. So now we have to fulfill and we have to verify all these 3 conditions that we have previously studied. I'm not going in detail in this video because we have already done that. So we are given with k is equals to 2 and p is equals to 0 as n power k log pn, n power 2 as k is 2 log 0n, as we are having an square. So we are having value of a but we are not having value of p. So we are having p is equals to 0, bk is equals to 2 power 2, that is 4. Bk is greater than bk is less than a, as a is equals to 7 and 2 power 2 means 4 is obviously less than 7. So we have to apply the condition. So we can see that a is greater than bk. From our question we are having a is greater than bk, so we will directly apply the answer for the time complexity, that is theta n log ba. So theta n log b की value is 2, b is equals to 2 and a is equals to 7. So a की power 7. So our answer will be theta n log base 2 7, right? So this is our answer. Log is not in power, it is 2 and power 7, right? So this is our answer, and this is the way we solve the questions. If you wanted me to solve more questions, do comment, and if you like the video, do like, share and subscribe my videos.